Okay. So here's the function that I'm going to use as an example. I'll use f of x is x over log x. And because the logarithm, yeah, question. Yeah, sorry.
I'm wondering for practical checking pointers up or down.
The question is this optional? So that's a good question. Is this optional? Okay, so the question is this optional? This kind of question? And the answer is, it's more than just, so in many instances, I'm going to ask you to do this. I'm going to ask you to find these things. In many instances, I'm not going to ask you to. I strongly recommend that if I don't ask you to do it, that you not try, because it's usually awful to find the second derivative. Anytime you can get away without computing a second derivative, you're better off. So in many, many instances. On the other hand, if I ask you to do it, it's because I want you to have the work to do it. But basically, if nobody forces you to, I would say never do step 4 here. All right? Yeah, other questions? All right, so we're going to force ourselves to do step 4, however, in this instance. But maybe this will be one of the few times. All right, so here we go, just for illustrative purposes. Okay, now, so here's the function that I want to discuss. And the range has to be x positive because the logarithm is not defined for negative values. So the first thing that I'm going to do is I'd like to follow the scheme here, because if I don't follow the scheme, I'm going to get a little mixed up. So the first part is to find the singularities, that is, the places where f is infinite. And that's when the logarithm, the denominator, vanishes. So that's f of 1 plus, if you like. So that's 1 divided by log of 1 plus, which is 1 over 0 with a little bit of positiveness to it, which is infinity. And second, we do it the other way, and not surprisingly, this comes out to be negative infinity. All right? Now, the next thing I want to do is the ends. So I called these the ends. And there are two of them. One of them is f of 0 from the right, f of 0 plus. So that is 0 plus divided by log 0 plus, which is 0 plus divided by, well, log of 0 plus is actually minus infinity. That's what happens to the logarithm. It goes to minus infinity. So this is 0 over infinity, which is definitely 0. There's no problem about what happens to this.